Imagine trying to describe the world without numbers. How tall is the Eiffel Tower? How fast does light travel? Without measurement, science would just be guesswork. Today, we're exploring the tools that make the invisible visible. The humble ruler seems simple, but there's a trick to using it right. Always line up your object with a zero mark, and look straight down to avoid the angle illusion that makes measurements wrong. See these tiny lines? Each one is 1 millimeter. That's about the thickness of a credit card. When millimeters aren't enough, scientists use this clever tool. It has two rulers that slide together to measure super small gaps, like the thickness of a coin or a strand of hair. This tool is called Vernier caliper. First, let's get familiar with the different parts. Hold your caliper in front of you. I'll point them out as we go. This long ruler-like part is the main scale. It's fixed and has measurements in millimeters or inches. The sliding part with smaller lines is the vernier scale. This is what gives us those super precise readings. Down here at the bottom, these are the lower jaws. They measure the outside of objects, like the width of a bolt. Up top, the smaller upper jaws measure inside dimensions, like the inner diameter of a pipe. And don't forget this thin row sticking out the end. That's the depth probe, perfect for measuring how deep a hole is. Finally, this little screw locks the sliding jaw in place, so your measurement doesn't shift. Now, let's measure something. I'll use this plastic block as an example. Before you start, close the jaws completely. The zero lines on both scales should line up perfectly. To measure the block's width, gently place it between the lower jaws and close them until they snugly touch the object. No need to force it, just a light grip. Then, tighten the locking screw to hold the measurement. Need to measure a hole or gap? Open the upper jaws, fit them inside, and gently expand until they touch the sides. Lock it in place just like before. For depths, extend the depth row into the hole until it hits the bottom. Keep the caliper straight for an accurate reading. Right now, let's get into reading the measurement. This is where people get nervous, but don't worry, it's easier than it looks. First, look at the main scale. Find the last whole number before the zero on the vernier scale. Let's say it's 17 millimeters. You see those little gaps? Each of them represent 1 millimeter. So here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. We have 17 millimeters. Next, check the vernier scale. Look for the line that perfectly aligns with any line on the main scale. For example, this line. It matches with the 5 on the main scale. But be careful, the vernier scale is in 0.02 millimeters, which means this line represents 66. Now add them together. 17 plus 0.66 equals 17.66 millimeters. That's your measurement. If your caliper uses inches, the same logic applies. Just watch the units. Next, we're going to talk about micrometer. A micrometer is used for higher precision length measurements, with an accuracy of 0.01 millimeter. It is commonly employed to measure the diameter of thin metal wires, the thickness of sheets, and similar small dimensions. As shown in the figure, the micrometer consists of fixed and movable parts. The fixed parts are the frame, the fixed anvil, and the main scale. The movable parts are the spindle and thimble, which are connected and threaded onto the main scale, with a rigid stop for protection. The locking lever secures the thimble in place. Right now, let's get into reading the measurements. First, we examine the fixed main scale. Notice there are two sets of lines. The lower set marks 4 millimeters, while the upper set marks half millimeter increments. We need to count how many of these half millimeter lines are visible up to our thimble edge. In this case, we clearly see 11 of these lines. Since each represents 0.5 millimeters, we calculate. 11 lines times 0.5 millimeter per line equals 5.5 millimeters. And this forms the foundation of our measurements. Now we look at the rotating thimble scale, which has 50 finely marked divisions. The center line on our fixed scale acts as our reference point, We see that the 17th line on the thimble aligns perfectly with this reference. Each thimble divisions equals 0.01 millimeter. So, 17 divisions times 0.01 millimeter per division equals 0.17 millimeters. This gives us our second measurement component. Here's where micrometers show their incredible precision. Look closely at how the thimble line aligns. It's not perfectly at 17, but slightly past it, about 30% of the way toward 18. This is where we make our careful estimate. We call this P, and in this case, P equals to 4. 0.001 millimeter times 4 equals 0.004 millimeters. This estimation to the thousands is what makes micrometers so valuable for precision work. Now we combine all three components. 5.5 millimeters plus 0.17 millimeters plus 0.004 millimeters equals 5.674 millimeters. What makes this special is that we're reading to 3 decimal places. The 5.67 is absolutely certain for our scale readings, while the 4 in the third decimal place is our expert estimation. This is why we call it a 1,000 scale measuring tool. We're measuring differences as small as 1 micron. To practice this yourself, first, always start by confirming your micrometer is properly zeroed. Second, tighten the ratchet until it clicks 3 times for consistent pressure. Third, lock the measurement before reading to prevent movement. Fourth, read from bottom to top. Fix scale first, then thimble, then estimate. Fifth, record all 3 components before doing the final addition. That's it. Now, you try it. Drop your measurements in the comments. I'll help. Like or subscribe for more pro tutorials. Stay precise, my friends.